Hello, here we'll start 2.3 and we'll talk about analyzing graphs of functions. Okay, here you have lots of notes that I want you to read by yourself. Of course, I'm going to post for you these slides. Okay, here we'll be talking about domains and range. Okay, look at this graph and we'll talk about the domain and the range for this graph. Of course, you know, once I'm talking about domain, that means I'm talking about x and the range is talking about y. So here, once I'm talking about the domain, look at the x. So it will be starting from -1 till what? Till 5. So this is the domain from -1 to 5. Of course, there is something about the open and the closed brackets that you already know before. And once I'm talking about the range, that means I'm talking about the y, which will be starting from here -3 to +3. So this will be my range. So you can decide domains and ranges of graphs by just looking at the graph. On the x, the interval for the x will be the domain and the interval for the y will be the range. Okay, here you have a note. If no such dots, I'm talking about these dots, if no such dots are shown, assume that the graph extends beyond these points. So if these dots were not there, this graph might be what? Extending more and more. So you cannot say that it's stopping at 5 or at 3 or whatever. By the way, once you see these notes, that means it's included, but this open, it means it's not included, like here. So that's the idea of opening and closing these intervals. Okay, let's have the next idea. Domain and range of graphs. For example, you can see for each and every one what are the domains and what are the ranges. It's already given here, and as I told you, I'm going to give you the slides. So for these types of graphs, for example, they are going to continue. So you'll say that all x values and here all y values, because they are going to continue, and same thing here. But this is a circle. By the way, this circle is not a function. I'll tell you later how to determine it's a function or not. Anyway, here you are given what's the domain and what would be the range. Good. Same idea here, you can revise it by yourself later. This talking about function, the idea that we've been talking about before, and here is the important idea. It says that a vertical line can intersect the graph of a function at most once. Okay, that means if you have a graph, let's say this is your graph. If you make a vertical line, this vertical line must touch the graph only once. If it is touching the graph only once, then we can call it a function. But in case of this circle, if you draw a vertical line, it will touch it at more than 1 point, so I cannot call it a function because the vertical line is going to touch it more than 1 point. For example, this graph, any vertical line is going to touch it once, so it will be a function. That's the idea of to determine a function. Okay, here let's talk about zeros of functions. What's the idea of zeros of functions? It means when f of x equals to what? 0. When f of x equals to 0, f of x means y equals to 0. So on the graph, zeros of functions are those x-intercepts where the graph will touch the x-axis. They are very important points to be capable of sketching the graph. So zero functions is the x-intercept where the graph is going to intersect the x-axis. Like in this example, look, these are the zeros, and also in this example, these are the zeros. Anyway, I'm going to solve these two functions or questions and show you how to find them, but the idea of zeros of functions are this. As I told you, it will be the x-intercept. Okay, let's solve it and see. The first question is saying okay, the first question or the first function is g of x equals to root of 10 minus x squared, and the second question is saying h of t equals to 2t minus 3 over 2 over t plus 5. I'll start with the first one. Once you say zeros of a function, that means, as I told you, f of x equals to 0 or whatever of x or whatever the function is going to be 0. So make this one equals to 0. So to find the value of this x, you're going to square both sides to get rid of this root. So it will be 10 minus x squared equals to 0 squared, will also give you 0. So what if I bring the x back? It will be 10 equals to x squared, because 0 plus x squared is just x squared. To find the value of x, put a root on both sides so that this can be cancelled. So x equals to plus or minus root of 10. So the value of x will be plus or minus root of 10. Good. Second question, again you have to make it equals to what? 0. And you can cross multiply here, assuming that it's 0 over 1. So if you cross multiply, 2t minus 3 times 1 will give you just 2t minus 3, and t plus 5 times 0 will give you what? 0. Bring the 3 back. 2t equals to 3. Divide both sides by 2. So t equals to 3 over 2. So this will be your solution. Good. Now, let's talk about the idea of decreasing constant and increasing functions. You can read these notes by yourself later. Anyway, we're going to say that a function is decreasing if you have a graph. This is your graph, and let's say that you have this graph. Okay, so here you can see that the function is going down, so that means it is decreasing, and here it is almost, I'm supposed to make it a straight line actually here, and here the function is constant, and on this point the function is increasing. So I think it's very easy to determine where the function is decreasing, constant, or increasing function. Yes, this is increasing and decreasing functions. So this for example a, this function is increasing over the entire real line, because here you can see it's going up and up, so it's just what? Increasing. And for question number B, here it's what? Increasing, decreasing, and then again increasing. This will be increasing, constant, decreasing. So it's obvious. It's clear, I hope. Sorry, I don't know what's happening. Yeah, here we want to talk about relative maximum and relative minimum. Let's say that you have a graph, and this graph will be something of this type. So here this point is relatively maximum. Look, relatively maximum to the other point. So on this point we will say that it's relative maximum, and here relative to the other points it's relative of what? Minimum, and again here it's relatively maximum. So this way you can decide where are the relatively maximum and minimum points in the graph. Same thing here, they're showing you where relatively it's minimum, and here so it's relatively minimum, and here you have relatively maximum points. Okay, here let's talk about even and odd functions. You can first, this is the most important idea, that an even function is symmetric corresponding or with respect to the y-axis, and odd function is symmetric with the respect to the origin. Or you have here two tests. This test is for even function. In even function, f of negative x will equals to f of x, and for the odd ones, f of negative x is going to be equal to negative of f of x. So you can use these two tests, or you can just look the graph is symmetry according to the y-axis or to the origin. Let's have examples here. Okay, look on this graph. In the first graph, it's actually odd, because let's say that you have these 2 points. So these 2 points are symmetric respecting what? The origin. Because if you are going to fold this part, if this part is folded, like you bring it here, you'll find what? You'll find that it's symmetric with respect to the origin. But here, if you fold this graph, you're going to fold it with respect to the y-axis, so that this point will be here. So this type of graph is even, because it's symmetric with respect to the y-axis, and here it is symmetric with respect to the origin. So this would be odd. And also, if you want to use those tests that you saw before, using the f of x, you can use them. Okay.